Okay.
Okay, so I'm going to keep going through the FRQ that we've been doing. So this time we'll be going through 2006 Form B. So we'll be looking at whether or not we can take a given equation with certain constraints and test to see whether it's okay within those constraints based on its derivative and second derivative and the function itself. But we'll also be talking about some changes to the AP exam this year. So we got an email over the weekend from College Board that said they're going to be changing the test to be taken at home this year. So you guys are going to have a 45-minute exam that you'll take at home instead of at the school. There's
Okay.
two different test dates. They have not announced the test dates for calculus yet. It's going to be different for every class. That way, if you feel like you're ready, you can take it straight away. And if you want to wait a little bit longer, you can take a little bit longer since we haven't had school.
Pardon, can you repeat it again?
Right. So your AP exams are now going to be 45 minutes online, and you'll take them at home.
Okay.
Um, it's a free response test,
But
so that's
isn't 40 minutes very short?
yes, that's much shorter than usual. Normally you'd have
Okay.
an hour and a half for the free response alone, and then an hour and 45 minutes total for all of your multiple choice. This is way shorter than usual. So there is no multiple choice. It's all free response, and you have 45 minutes. So they could just give you 3 free response questions, and that's it.
Oh, okay.
We're also not covering all of the topics that we would normally cover in AB. Now, we're content complete, and we have been for a while. So that means there's just some topics that you guys don't need to study for the AP exam. So I've listed those here. All of Unit 8 has been canceled. So if you look at from the very start of the year, we passed out links to a course exam and description guides. That's kind of an overview of everything there is in AP calculus. So that's applications of integration has been cut completely. So all of these topics that I've listed here, you guys will not be tested on. Some of this I do think is actually a disadvantage for you guys because you're both really strong on disk and shell method, which is all of this volume stuff,
Yeah.
which I was kind of hoping would balance out some of our curve sketching and stuff. But we won't have any disk or shell method. What might help you is you also don't have any accumulation functions. That's the application of integration, which is kind of like advanced related rates. Which you guys have been doing better on over the past couple weeks, but was an area of weakness for the midterm. So with that, I'm expecting your free response questions will be mostly derivative based. So you can expect curve sketching, you can expect rates of change. You can probably expect some Riemann sum stuff. So that would be kind of leaning towards this accumulation function, but it wouldn't be using integration directly. So they might. Notice here, Unit 6, they've got integration and accumulation of change, which makes me think if the free response questions related to integration, if they can't be geometric, are probably going to be rates of change based. Okay, so with that in mind, I had planned to go through some disk and shell method stuff today, but I won't anymore. I am going to keep the disk and shell method stuff on the homework because you will be expected to know it once you've got this on your transcripts after you pass the AP exam. But I'm going to try to avoid it for the questions that we'll spend in depth talking about in class. Just before I go up. Any questions on changes to the AP exams?
They said that we had 2 tests or one.
So you're going to have 2 different test dates, and you can pick which one you want to take.
Oh, okay.
They have not announced the dates yet. They will announce them on April 3rd. So we've got a little bit of a wait before you'll know when your tests are going to be.
Okay.
Um, although AP Calculus has never been done online like this, College Board has administered online courses for other classes before. And they've also taken emergency measures in the past for some areas of the world that have required it, that have been similar. So they've got experience doing this. I will link in WeChat.
Well, I think the biggest problem is gonna for integral and everything, and that's gonna take time.
Say one more time. The biggest problem is what?
I think that the time is too short because when we have to type in, we have to click everything, right? So that's gonna take more
Right.
time than usual too.
Okay, so they are letting you handwrite.
So you have to be really, really fast.
They are letting you handwrite, and you can take pictures of your handwritten stuff. So that won't be an issue.
Uh, uh,
However, I am expecting once you click the button to
that's
start,
fine.
you'll be timed at 45 minutes. So you'll have to submit by the end of that 45. We'll know more about the exact format, and they'll have some practice tests available at some point in April. I am going to link in WeChat and on Skype later for some resources that College Board has already made available leading up to this. Because a lot of schools in the United States are closing, they've taken some of the top teachers and have them making really well-produced YouTube videos. So if you guys want to check those out, they'll be covering the last 25% or so of the content. And I'll link to that as well.
And where? Oh, okay.
Okay, any other questions?
Oh,
Okay, no. Junho, your mic's a little bit quiet for me, I think. Can you say one more time, are you okay?
Oh, yeah.
Okay. Alright, so we'll go back and keep doing our free response as normal. So here we've got an equation, a function that's modeling the height of a skateboard ramp. And it meets these following three requirements. At x equals 0, the value of the function is 0. And the slope is 0. So I could say f of 0 is 0. F prime at 0 is also 0. Rule number 1. Rule number 2. At x equals 4, the value of the function is 1. F of 4 is 1. And the slope of the function is also 1. F prime at 4 is 1. Okay. And rule number 3, between x is 0 and x is 4, the function is increasing. So f prime x is greater than 0, is positive. On the interval between 0 and 4. So those are both parentheses because we're not including 0 and 4, the endpoints. Okay, so with all three of those rules, we're going to start by letting f of x equal ax squared, where a is a non-zero constant, and show that it's not possible to find a value for a such that we meet requirement number 2. Any ideas on what we can do?
um,
So the English is asking us to test rule number 2. So if I want to test rule number 2, that's this one. Using f of x equals ax squared, what would have to be true about the function itself? What is f of 4?
1.
Okay, f of 4 has to be 1 according to rule number 2. And f of 4 also has to equal ax squared. So that's some constant a times our x value, 4, squared. So that means we can solve for a. So what should a be?
1/16.
1 over 16. Okay, but then the derivative at 4 also has to equal 1. So the derivative of x would be, if this was ax squared, 2ax, and therefore f prime at 4 would have to equal what?
2 times 1/6 times 4.
Okay, or 1/2, which is not what we should get with rule number 2. Okay, so this is not the function we want. I could say something like, if f of 4 must equal 1, then a equals 1/16. But if a equals 1/16, f prime at 4 does not equal 1. Okay, any questions on A?
No.
Okay, going to B. We are told g of x is equal to cx cubed minus x squared over 16, where c is a non-zero constant. I want to find a value of c so that rule number 2, is true. What's our first step?
G of 4 equals C 4 raised to the 3rd power minus 1. 16/16.
Right. I'm going to go ahead and show that plugging in step because sometimes that's worth a point. And then g of 4 should equal what?
Should equal to
Okay, this is 64c minus 1. But what should g of 4 be equal to total?
1/46. 64.
I think you're solving for c, but what should g of 4 be, according to rule 2?
1.
1. Okay, so then I can set 1 equal to 64c minus 1. And solve for c. So therefore 2 equals 64c, or c must equal 1 over 32. Okay, then if that's true, we can check the derivative. So we can also say g prime at c should be equal to what? Or g prime, do the general form for x first. G prime x is equal to what?
1 over 32.
Okay, 3cx squared minus x over 8. And then g prime at 4 should be equal to
3c times 16 minus 1 over 2.
okay, so that's 48c minus 2 minus 1 half is g prime at 4. And then we said c is what? Oops, 48c. 48c minus 1 half. This is 48 times, what's our c?
1 over 32.
1 over 32
Or 32.
minus 1 half. Okay, so this is 48 is 16 times 3. 32 is 16 times 2. So this is 3 halves minus 1 half, which is 1. Okay, so we could say g at 4 implies c equals 1 over 32. And if c equals 1 over 32, g prime at 4 is 1. Okay, any questions on what we did?
No.
Okay. So we're going to use that function g and our value c from part B and prove that we don't meet the requirement for 3 above. So I'm going to keep what we have right now. That's g prime at 4. Just get a general form for x, actually. So g prime x is 3cx squared minus x over 8. And then we said c is 1 over 32. So that's 3x squared over 32 minus x over 8. Okay, I need to prove that between 0 and 4 the function is increasing. So what do I have to do?
Find the slope.
Okay, we've got an equation for slope already. So this is g prime x. I'm going to simplify just a little bit.
Plug in x and see if it's positive or negative.
Right. So what I'm going to do is I'm going to factor this out. That way we can see what our breakpoints are going to be. So if I set this equal to 0, in order to change from a positive to a negative value, we have to pass through 0, right? So I'll factor this out and set it equal to 0. So this will be 0 is equal to. I'm going to pull out 1 over 8 since I've got that in both terms, and I'm going to pull out an x. This is x over 8 times 3x over 4. minus 1. Okay, so I can use that to test my breakpoints. I'll have a breakpoint at x equals 0, or I'll have a breakpoint at x equals 4/3. And then we can do a first derivative test to see what's happening around those 2 points. So if I plug in -1, will the slope be positive or negative? Oop, g prime, not x, f. If we plug in -1, will this be positive or negative?
-1. Positive.
Okay, so this will be...
No, 0.
if I plug in -1, so this will be a negative times a negative, which is positive. I'm going to change color really quick. So, what about if I plug in 1?
Positive.
If I plug in 1, the 1/8 is positive, but the 3/4 minus 1 is negative, so that's a positive times a negative is negative.
Huh?
If I plug in 10,
Positive.
positive. Okay, so that's 10 over 8 is positive, and then 30 over 4 minus 1 is also positive. Okay, so that means g prime x is only negative on the interval from 0 to 4/3. G prime x is less than 0 on the interval from 0 to 4/3, which does not satisfy. Rule 3. Any questions on this one?
No.
Okay, last one. So we've got h of x is x to the nth over k. K is a non-zero constant, and n is a positive integer. X to the nth over k. Find the values of k and n such that we meet the requirements of 2, and then prove once we've met 2 that we also meet 1 and 3. Okay, so again, what do I have to do to test rule number 2?
The derivative is equal to 1.
Okay, the derivative must be equal to 1, and the value when x is 4 is equal to 1. I'm going to test the value first since we already have the function here, and then we'll test the derivative after that. But you're right, we need to test both. So this is h at 4 equals 4 raised to the n power over k. And h at 4 must equal 1. Therefore, 4 raised to the n power is k. Okay, now I'll go and I'll test the derivative like you wanted me to. If k is a constant, then what happens when I derive x to the nth over k?
A F4 over N ln A ln 4.
H to the x is here. So I'm not deriving k, I'm deriving h of x.
Oh. So N x n minus 1.
over k. So k is a constant, so that's going to stay the same. And then if I derive x to the nth
Oh.
power, I get nx to the n minus 1, right? Okay, we were told the slope at 4 is 1. Therefore, 1 must equal nx to the n, where x is 4. 4 to the n minus 1 over k. Okay, so I've got k equals n times 4 to the n minus 1. 4 to the n minus 1 is the same thing as 4 to the n over 4. So n over 4 times 4 to the n must equal k. So if k is 4 to the n, then 4 to the n must equal n over 4 times 4 to the n, which means n must equal what? Right. So n is 4. Okay, n is 4, and k is 4 to the n power. And if that's true, then we satisfy rule 2.
Okay.
Okay, so that means to satisfy rule 2, k must equal 4 to the n power, where n is 4. So that's 4 to the 4th power, or 256. 4 times 4 is 16, times 4 is 64, times 4 is 256. And n equals 4. Okay, so if that's true, where n is 4, k is 256, then we need to show that we also meet the requirements for 1 and 3. Okay, so I'm going to give us one extra slide. We said n is 4, k is 256. Prove that rule 1 is okay and rule 3 is okay. H of x equals x to the 4th power over 256 then. Okay, what do I have to do to test rule 1?
We said that we plug in 0 for x.
Okay, h at 0 must equal what?
Zero.
Okay, so that's 0 to the 4th power over 256. Therefore, 0 equals 0, and we're okay. Okay, and then what about the slope?
It should increase
Okay, for rule number 1,
between 0 and 4.
I'm still testing rule 1 first.
It's 0 too.
The slope must also be 0 at x equals 0. Okay, so If I derive h of x, what would I get?
4x cubed over.
Okay, 4x cubed over 256, and the 4 and the 256 can cancel. So this will be x cubed over 64. Since that 256 was 4 to the 4th power, it'll become 4 to the 3rd power. Okay, so this is 0 equals 0 cubed over 64, or 0 equals 0, which is also true. Okay, for rule number 3, how do I test it?
We plug in.
Zero.
Okay, so between 0 and 4, we need to prove that this function is increasing. This function will only equal 0 if x is 0, right? So we can test 1 point above and below 0 to see if we are positive or negative for our slope. If I plug in a negative, is this h prime x positive or negative? So if I plug in -1, is h prime x positive or negative?
Positive.
What's -1 cubed?
Oh, negative.
Negative, okay. And then what about if I plug in +1?
Positive.
Positive. Okay, so we are increasing as long as we are above 0. Okay, so we could say h prime at x is greater than 0 if x is greater than 0. Therefore, rule 3 is also true. Okay, any questions on anything we did?
No.
I feel like this one was more difficult because of English than the math itself, but
Yeah.
that's part of the reason why I wanted to do it with you guys. Okay, so I'm going to leave this PowerPoint with the annotations up for you now on WeChat. Save
Okay.
this as a separate file in case you guys want to test yourselves later. Then starting next class, I'm still want to do free response questions because it looks like your AP exam is all free response questions now. But I'm going to start doing short, like 5 to 10 minute review lessons beforehand, just so we can kind of beef up.
Okay.
If you guys have homework questions, I can take those too.
Okay.
Okay, thank you guys very much for coming, and I will see you on Thursday.
Okay. Thank you.
Oh, right, homework too.
Bye.
Sorry. The homework is the free response questions 1 and 2 on that form that we sent through WeChat, since we did 3 today.
Okay.
Okay, thank you very much. I'll see you guys later.
Bye.
Goodbye.